So today we'll take up the numerical problems in the phase and frequency modulation. So first we'll list the formulas. So first is general equation of the angle modulated wave, which is written here. St is equal to AC sine of theta it. Theta it will differ depending upon whether it's a AM wave or it's a FM wave or a PM wave. Okay, whether it is frequency modulation or the phase modulation, it will differ. Okay, the total power of the both the FM signal as well as the PM signal is written as AC squared by 2R. Okay, this is the modulated signal AC squared by 2R. So general equation for FM wave, where we can replace the theta it by 2 pi fct plus 2 pi kf integral mt dt, where mt is the message signal or baseband signal, or the signal which contains the information, or modulating signal, whatever you call it, right? So that mt is am cos of 2 pi fmt. Okay, you can try to write this also as this is the most used equation rather than this. You can use this or this, right? Either of the two you can use. So this is beta sine 2 pi fmt or 2 pi kf integral mt dt. Then we have the instantaneous frequency of the FM signal, which is written as fit equal to 1 by 2 pi d by dt of theta it. Okay, this is the instantaneous frequency of the FM signal, where theta it is the angle of the FM signal, which is written over here. So whatever we have here, or we can say this or this, depending upon whether it's a FM or PM signal. Here we are talking about FM only, so it is this. Okay, theta it means this, that should be differentiated with respect to dt. So therefore, it will be 2 pi fc, because if you're differentiating this with t, you'll get 2 pi fc plus again you need to integrate it and then differentiate it, whatever we have. So theta it is the angle of the FM signal. Maximum frequency deviation is written as del f max is equal to kf am equal to beta fm. Okay, kf am or beta fm. So maximum frequency deviation is written as kf am or beta fm. You can sometimes people will write kf is equal to del f max by am, or beta is equal to del f max by fm. So this formula is a general formula which should be remembered. From this you can find the beta value, you can find the kf value. Kf is known as frequency sensitivity, beta is known as the modulation index. So beta is from the above only we can find del f max by fm. Now you can have beta less than 1. When beta is less than 1, it is known as narrow band frequency modulated signal. If beta is greater than 1, then it is known as wide band frequency modulated signal. The what you call carrier frequency swing is known as the 2 del f max. 2 del f max, that is deviation is del f max. Both the sides, if you take the deviation, then that will become the frequency swing. Then you have the bandwidth. Bandwidth will be 2 fm plus 2 del f max. When we talk about the wideband FM signal, that is known as the Carson's rule, where FM is the modulating frequency and the del f max is the deviation. So sometimes we'll write 2 common. In the bracket, you'll just write FM plus del f max. Okay, that is the one which is for wideband FM signal. For narrow band FM signal, we just take only this because deviation at that time is very small. Okay, deviation is very small. When beta is less than 1, then we see that when beta is less than 1 here, okay, or here beta is less than 1, then del f max is only small part of the FM, small part of the FM. So therefore, we will try to write here. So sometimes we write here 2 FM into 1 plus, I think, might be beta. 1 plus beta, 2fm into 1 plus beta. So if beta is very small, then you can neglect it compared to 1, and then you are left with 2fm. Okay, but ideally this is the formula which should be used for bandwidth. Only when beta is very, very small, you can write this. At that time, del f also will be, del f max also will be very small. Let us take some of the numericals. So here, the first one is the equation for an FM wave is given here. ST 10 sine 5.7 into 10 to the power of 8 t plus 5 sine 12 into 10 to the power of t. Calculate carrier frequency, modulating frequency, modulation index, frequency deviation, power dissipated in 100 ohms. So all these are very simple. The first three are straightforward. Carrier frequency, if you want. Now this carrier frequency is associated with this. This can be, you can try to write that equation itself. Okay, same thing, whatever is there here, we are repeating here. And then we are trying to write the standard equation form, which is AC sine 2 pi FCT plus beta sine 2 pi FMT. So from this, you can make out that FC is, or 2 pi FC is this quantity. Therefore, FC will be 5.7 into 10 to the power of 8 by 2 pi. Beta, as it is equal to 5. Then 2 pi FM is equal to 12 into 10 to the power of 3. That will give us FM is equal to 12 into 10 to the power of 3 divided by 2 pi. So therefore, we'll get here the carrier frequency, which is FC equal to 5.7 into 10 to the power of 8 by 2 pi. This divided by 2 pi, and that will be 90.7, megahertz. Modulating frequency is the FM value. FM value is 12 into 10 to the power of 3 by the value 2 pi, and that is what we have written here, which is 1.91 into 10 to the power of 3, that is 1.91 kilohertz. Modulation index straight away given there as 5. Then we have the fourth quantity, frequency deviation, and then the fifth quantity, power dissipation in 100 ohms. So the, what you call frequency deviation, okay, del F max can be found by using the equation which is known as, del F max is equal to beta into FM. It's also, KF into AM, but AM is not given. KF is also not given, but beta and FM are given there. So del F max is equal to the beta into FM, and that will give us 5 into 1.91 into 10 to the power of 3, and that is equal to 9.55 into 10 to the power of 3 hertz, that is 9.55, kilohertz. Then power dissipated in 100 ohms is PT equal to AC squared by 2R. AC is 10 squared by 2 into 100, and that will give us 100 by 2 into 100, that will be equal to 0.5 watts. Let us take the second numerical. When a 50.4 megahertz carrier is frequency modulated by a sinusoidal AF modulating signal, the highest frequency reached is 50.405 megahertz. So this is the highest frequency. Calculate frequency deviation produced, carrier swing of the wave, lowest frequency reached. So very simple here. This is 50.4 and this is 50.405, highest frequency. So deviation will be difference between these two. That is 0.005 megahertz, and that will give 5 kilohertz. Then carrier swing will be double of that, deviation, and that will be, 2 into 5 equal to 10 kilohertz. Lowest frequency reached, this is the highest frequency reached. Okay, this minus this will give you the deviation, and naturally this minus the 5 kilohertz, that will give us the value 50.395 megahertz. So that's what we have calculated here. You can see that del F max is FIT max minus FC, that will give us 5 kilohertz. Carrier swing is double of that, that is 10 kilohertz. lowest frequency is FC minus del F max, that is 50.4 into 10 to the power of 6 minus 5 kilohertz, that will give 50.395 megahertz. And this is how the figure looks like. This is the maximum and this is the minimum. Okay, this is the maximum and this is the minimum. This is the signal swing. So FIT is given over there on the x-axis, on the y-axis, and T on the y-axis. Let us take the third one. An angle modulated signal is defined by the equation given there. Power in the modulated signal is what we need to find. The frequency deviation del F, the approximate transmission bandwidth. So again, we can write AC cos of 2 pi FCT plus beta sine of 2 pi FMT. Okay, that's what we have written here. So AC is 10, FC is 10 to the power of 6, beta is 0.2, FM is what you call 2 pi FM is 2000 pi, and that will give us the value which is FM equal to 100, 1000. So there's a confusion here. This is 200 and this is 2000. Let us consider this 2000 only. We can assume that this is also 2000. So don't bother much about it. Now you can write all those values. So what do you want? Power. Power is AC squared by 2R. R is not given there, so we assume R, and that will give us the value AC squared by 2 into whatever R. R is considered. If it's not given, we assume 1 ohm, and therefore we will get just AC squared by 2. AC squared by 2. That is 50 watts. Frequency deviation you can find by writing beta FM. Beta is given there, 0.2. FM is 1000 hertz, and therefore the frequency deviation will be 200 hertz. Transmission bandwidth is we can write the formula, either Carson's formula, or for narrow band it is just 2 FM. Otherwise Carson formula means 2 multiplied by FM, 2 bracket of FM plus del F max, or 2 FM plus 2 del F max. So because the value of beta is 0.2, which is less than 1, we are just taking narrow band formula, that is 2 FM, that is 2 into 1000 equal to 2 kilohertz. However, if we don't neglect that beta value, then we will get 2 FM plus 2 del F max, and that will give you the value del F max is equal to beta into FM. Beta is 0.2, FM is the value of FM is 1000, and therefore del F max we have got it here as 200. So exact value if you want, it will be 2 FM plus 2 del F max, and that will be 2000 plus 2 into 200, that will be 2.4 kilohertz. Okay, exact value if you want, it is 2.4 kilohertz, but for considering the narrow band FM signal, it will be 2 kilohertz. So that's an additional thing. Say if you want the exact value, it will be 2.4 kilohertz. Here you might have asked approximate value. Yes, he has asked approximate transmission bandwidth, and that is associated with assuming beta is very, very less than 1. That is narrow band case. Let us take the next problem. ST is equal to 10 cos 2 plus sine 6 pi t. Find instantaneous frequency. So this value which is given over here, 2 plus sine 6 pi t, is theta, right? This is theta, and therefore we take that out, and FIT you can write instantaneous value as 1 by 2 pi d by dt of theta it, and d by dt of 2 plus sine 6 pi t is what we have here. If you differentiate this 2 with respect to t, you will get 0. If you differentiate this sine, then you'll get 6 pi cos of 6 pi t. So that will give us the value which is 3 cos of 6 pi t. Fifth problem, a sinusoidal modulating wave of amplitude. So this is modulating wave. Please remember that there's a difference between carrier wave and modulating wave. Amplitude is 5 volts, that is FM is 5 volts, AM is 5 volts, and frequency, that is FM is 1 kilohertz, AM is 5 volts, FM is 1 kilohertz, is applied to a frequency modulator. The frequency sensitivity of the modulator is 50 hertz per volt. Frequency sensitivity means it is KF. Okay, the carrier frequency is 100 kilohertz. Carrier frequency is 100 kilohertz, that is FC is 100 kilohertz. Calculate frequency deviation and the modulation index. So AM is given 5 volts, FM is given 1 kilohertz, KF is 50 hertz per volt, FC is 100 kilohertz. So frequency deviation del F max is, for us, KF and AM are given now, beta and FM or beta is not given, FM is given, beta into FM also you can write, but beta is not given there. So therefore, we can try to find here directly. 50 KF into AM is 50 into 5 equal to 250 hertz. Then modulation index beta is equal to del F max divided by the value which is FM, that is 250 by 1 kilohertz, and that will give 0.25. So because this beta is less than 1, you can say that this is referring to the what you call narrow band FM. Now let us take the sixth question. In an FM system, when the audio frequency is 500 hertz and modulating voltage is 2.5 volts, the deviation produced is 5 kilohertz. If the modulating voltage is increased to 7.5, calculate the new value of the frequency deviation. So now again, you can see that the audio frequency, audio means message, okay, or FM. FM is 500 hertz. Then modulating voltage is AM equal to 2.5 volts. Frequency deviation produced is 5 kilohertz. If the modulating voltage is increased to 7.5 from 2.5, calculate the new value of the frequency deviation and calculate the modulation index in each case. So let us find the modulation index in the first case, and then we can go for the second case. FM is 500 hertz, AM is 2.5. This is 2.5. It's not 2 is not visible here. Del F is 5 kilohertz. So del F is equal to KF into AM. AM is given there. So KF is what you can find. KF is equal to del F by AM equal to 5 into 10 to the power of 3 divided by 2.5. That is 2 into 10 to the power of 3. That is 2 kilohertz per volt. It should be volt. 2 kilohertz per volt. Here he has not written per volt. Please note that. Then beta is equal to del F by FM. That is del F is 5 into 10 to the power of 3 divided by 500. That will give us the value 10. Beta greater than 10 will just give us the wide band frequency modulation. So might be that if the bandwidth is asked, you can try to find 2 FM plus 2 del F. Okay, because beta is greater than 1. And del F itself is beta into FM. So one can write 2 FM into 1 plus beta. Beta is large, that is 10, so it will be 2 FM into 1 plus beta will be 11. So 2 into what bandwidth if it asks, we can easily find out. However, in the case 2, here, if the value of the modulating voltage AM is increased to 7.5, then how much is del F and how much is beta is what he is asking. Okay, what is the frequency deviation? That will be del F, and what is the modulation index? That is beta. So AM is 7.5, del F is question mark, beta is question mark, del F is equal to KF AM, del F KF is 2, KF is calculated as 2 kilohertz, 2 into 10 to the power of 3 kilohertz per volt multiplied by 7.5. That will give you 15 into 10 to the power of 3, that is 15 kilohertz. Okay, this is in volts and this is in kilohertz per volt. So volt to volt will cancel and we'll get 15 kilohertz. Beta will be now del F by Fm, that is 15 into 10 to the power of 3 divided by 500, that will give us the value 30. Now let us go to the 7th problem. The carrier swing of the frequency modulated signal is 70 kilohertz and the modulating signal is 7 kilohertz sine wave. Okay, so carrier FC is 70, FM is 7 kilohertz. Determine the modulation index of FM signal and the bandwidth. Okay, modulation index beta. Okay, so carrier swing is given as 70 kilohertz. It's not the what you call carrier frequency, it is carrier swing. So beta will be del F max, which is the carrier swing divided by the FM value, 70 by so to say the value of okay, del F max is just the deviation, so twice of this deviation will be the carrier swing. So therefore the del F max will be 70 by 2, that will be 35, right? Del F max will be 70 by 2, that will be 35. So beta will be 35 by 7, that will give us the 5 greater than 1, so it is a wideband signal. So once we have found that, then now we need to find the bandwidth. The bandwidth is 2 FM into 1 plus beta. 1 plus beta is 1 plus 5 equal to 6. So that will be 2 into FM. FM will be 7 kilohertz into 6. That will be the value. 70, I think it's 84. Okay, it is 84. 1 plus beta is 6, 6 into 2 will be 12, 12 into 7 will be 84, right? So you can write the way in which you want. You can write this formula, or you can write 2 into Fm multiplied by, in the bracket, 1 plus beta. So with this we come to the end of the numericals. We'll take up the transmission bandwidth of the FM signal in the next class. If you have any doubts, you can ask.